Hello my peeps. This Algebra Nation video will cover the right side of page 120 and we'll do part of page 121, left side. And if you do this on the EOC, taking it to the house, baby, getting big, you will definitely get a 399 or higher. And if by some strange chance you forgot your glasses at home, well, let me describe to you what's happening. This is an epic dunk on, that's right, your eyes may not be deceiving you after all, the Miami Heat. Yeah, buddy.
Here we're going to do a factoring rule known as difference of squares. What you're going to notice is there will be nothing in common at first, but they're all squares. They're all perfect squares. So speaking of perfect squares, let's go back and remind you guys how to deal with perfect squares right here. So do you remember your perfect squares from 1 to 12? Because you need to. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is... Let's do that. Oh, don't look at that. Don't look at that. Okay. Here we go. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. Pause the video, write that all down. Because you need to know your perfect squares. You need to know these. Or be able to put them in your calculator, right? You can always do that if you need to. 12 times 12 is 144. Hey, got this to help. Pause and write them down. I know that was fast, but again, hopefully you remember some of these. So in short, you got to remember your squares. You're going to take the square root of numbers and take half the exponents. So the quick way to factor this is, ready? 49, that's a perfect square. That's 7 and 7. E to the fourth, that would be cut it in half. E squared. And 100, that's 10 times 10. So then, to finish factoring this, because I just went ahead and rewrote them all as perfect squares, we're going to copy what's inside 2 times. We're going to have 7e squared 10, 7e squared 10, and that's actually the factored form, 1 plus 1 minus. The reason why is because the opposite of factoring would be distributing, FOILing. So if you watch for just a second, I'm going to go backwards to check. I'm going to FOIL this out. Ready? First, 7e squared times 7e squared is 49, because 7 times 7 is 49. E squared times e squared, 2 plus 2 will give you e to the fourth. Outer, 7e squared times negative 10. 7 times negative 10 is negative 70 e squared. The inner is plus 70 e squared. And the last is minus 100. And notice, if you have identical terms, one positive, one negative, the middle terms, they cancel. And we're back to the original problem. We are back to the original question. But this is how we're going to factor overall. Again, you're going to go ahead and take the perfect squares, take the square root of any of the numbers, take half of any of the exponents, and then rewrite one with a plus, one with a minus. But here's the catch. This is the second rule. We did GCF as well. You could also have a GCF and then a difference of squares. So remember, you always want to go ahead and see if there's anything in common, factor it out. And then you might have another rule. So in this case, I see that I have a C that I can factor out. If I factor the C out, I'd be left with e squared minus 36. And these are all perfect squares. So ready? That would be parentheses, parentheses. Instead of e squared, take half of it, which would be e and an e. 36, the square root of that is 6. A 6 and a 6. Make one positive, make one negative. And that factor of C, you drop down. So you might have to do GCF followed by difference of squares. So as usual, we need some practice here. So let's look at a few. G squared minus 16. Check this out. Ready? That's a perfect square. That's a perfect square. Parentheses, parentheses. G squared, that'd be a G and a G. 16 would be a 4 and a 4, one with a positive, one with a negative. That's how you're going to factor a difference, a subtraction, a difference of two squares. Like this next one, 64c squared minus 25. 64 is going to be 8 times 8. And so with that, 8 times 8, we're going to go ahead and split it up into each set of parentheses. Then, we got to move it aside. 1 plus 1 minus. C squared was a C and a C. 25 is a 5 and a 5. And so your final answer is 8C plus 5 and 8C minus 5. So once again, parentheses, parentheses. Square root of 64, 8 and an 8. C squared, C and a C. 25, square root of that, 5 and a 5, 1 plus, 1 minus. And that's how you factor difference of squares. 18 and 8 are not perfect squares, but you should always look to see what's in common first. 18 and 8 are both divisible by 2. So if I factor a 2 out, 18 divided by 2 is 9. Leave the g squared alone. 8 divided by 2, that'd be actually negative 4. And now I have a difference of squares. Now I have a difference of squares because 9 and 4 are perfect squares. So I'd have a parentheses and a parentheses. 9, square root of that is 3 and 3. G squared, take half of the power, that's 1. G and a G. 4 would be 2 and 2, 1 plus, 1 minus, and you bring the 2 down. So with that in mind, I did 3. I went